about the neighborhood strategies, exploration strategies, and the first one is first improvement. Idea is that you are evaluating neighbors until you find one which is better than the current solution. So the pseudocode of this strategy is if we got a solution, let's say S, then you produce a neighbor applying change I on the current solution, and if S prime is better than S, then you make a move. And this is usually included into a loop where you evaluate all the possible changes. So as soon as you find this change that produces a solution better than the current solution, you accept this solution and exit the loop. And this is repeated while you are finding such better solutions. So usually this is included into a while loop. You repeat this process. Improving could be a flag variable where initially is set to true. Improving true. Here you set improving to false. And in case you find a better solution, then you set improving to true again. So you enter this loop again, a new iteration. Regarding best improvement strategies, the idea is that you pick the best neighbor. So you have to evaluate all the neighbors. And if S prime is better than the best neighbor, then you update this best neighbor. Initially, the best neighbor can be set equal to the current solution. This is not done for every meta heuristic, but it is safe in this case. And afterwards, you update the current solution with the best neighbor. And again, you introduce this code into a while loop while improving, which is initially set to true. This way. Well, which neighborhood exploration strategy is better? Well, that depends. In this case, if we could move from one position to eight, every of the eight neighbors, then if we start in this cell, then we will get to this point, which is not the best solution. If we apply best improvement strategy, but if we apply first improvement strategy, there is a possibility of moving this way. This neighbor which is better, this neighbor which is well, yes, this neighbor which is better, actually this neighbor which is better, and finally this neighbor which is better. You will not always end up in this solution, but at least your probability of getting to this point is not zero in this case. In any case, there are some problems for which best improvement is better than first improvement. So it is not clear. It is interesting to test both exploration strategies, but there is something which is really clear, which is that first improvement iterates faster than best improvement because the neighborhood exploration does not need to be complete. You will stop that exploration and make a move before best improvement.